Welcome, ladies and gentlemen, to your math lesson. We're going to go on 1.3 algebraic expressions. This is for grade 7 math in Mr. Ewart's class. You should have a copy of the textbook with you. As I usually say, if you don't have a copy of the textbook with you, you can go to mrewart.edublogs and grab a PDF of it. Just search 1.3. And if you don't know any of the stuff I'm talking about, then you're just a creeper watching this video. I'm sure you're welcome here, but this is for my students. So what are you doing? Algebraic expressions. So the first thing, when we talk about algebra, kids usually go, oh my gosh, that sounds really complicated, but it doesn't really have to be. When you first did algebra, probably it was in like grade 2. You probably saw 4 plus something equals 6. You guys know the answer, right?
Yeah.
Well, yeah. What's the answer? 2. All right. But in algebra, we would say like, 4 plus x equals 6. We're saying, what does x equal? And you just identified x equals 2. Let's get a little technical on this, though. If we want to figure this out officially on paper, because Mr. Ewart always said, you need to show all your work. And this is where the kid goes, well, yeah, but I just know it. Well, yeah, but I need you to show it. Well, then usually the kid would go, well, I suppose you could say, like that. And I'll say, how did you get that? Well, I just know it. Okay. Well, here's how we do it in algebra. How do I get rid of this 4? How do I get rid of a 4?
Minus 4.
Yes, Helga.
Minus 4?
Minus 4. So I'm going to minus 4. But wait, hold on. Because we did a little bit of this the other day. If I do something to one side, I got to do it to the other side. Because this says equal. And equal means like a balance, right? Now, I really highly advise you, go onto mathantics.com and watch the video on algebra as well. He has a visual of this, and it's on the blog. In fact, it's probably part of your assignment, because I always post that guy with these. But I got to do the same to the other side, because if I do something to one side, it gets unbalanced. I got to put it on this side as well, so that you actually balance it out. So that cancels, minus 4 plus 4. Now I got x equals minus 4 plus 6. X equals 2. Now you've shown all your work. But that's getting a bit technical. But hey, it's math, that's what we're here to do. There's a few terms, though, that are going to come up. Those terms are variable, numerical coefficient. What's the third one? Oh, and then just the number, which is the numerical constant. These look like big scientific terms, don't they?
Yes.
Yeah, okay. Well, let's simplify this just a little bit. In our first problem, we had 4 plus x equals 6. Can you identify something that might be a numerical constant? Think about these words. Numerical constant. If something's constant, what does that mean? Yeah. Stays the same. Are there any of these that are a definite value, like they're going to stay the same? Yes, sir. Simon, we'll call you. Do any of these stay the same no matter what? Like you know for sure what it is? Yes, Winifred.
Oh, the 6.
The 6, yeah, the 6 is the 6, right? The 6 isn't going to change. There's always going to be a 6. It's a number that does not change. So this is a numerical constant. All right. Now, a few years ago, I had this Jimmy in my class, and Jimmy, I said, well, can you solve for x? He goes, well, I don't need to. I said, why? He said, I already know what x is. How do you already know what x is? Did you do it in your head? No, we did it the other day. What do you mean? He said, well, the other day, you said that 1 plus x equals 5. Okay. So we found out x equals 4. Okay. So I already know x equals 4. And I said, no, it doesn't. This is 4 plus x. If x is 4, that means 4 plus 4 equals 6. Does 4 plus 4 equal 6? It's like, no. Mr. Ewert, you must have written it wrong. I said, oh, I get it. You think this is a constant. You think that once we solve it, that's always going to be x. Is x a constant or does it change?
It's changing.
Do any of these words mean something that can change? Yes?
Normal constant.
No, coefficient doesn't mean change. Yes, Helga? Do any of these mean something that could change?
Variable does.
Variable. Excellent. This is a variable. So we got a numerical coefficient and a variable. Sound good? Okay, we've taken down 2 of these terms. We don't have numerical coefficient yet. I'm going to show you an example. Here we go. What if I said that Jonathan over here gets an allowance? And Jonathan's allowance is $7 a week. And he gets that allowance, let's see, he's saving up, he wants to have some money over Christmas holidays. He currently has 0. And I believe there's 3 weeks to Christmas, isn't there? Okay, well I would say 3 weeks times whatever Jimmy's allowance equals how much money he's going to get. I know he's going to have 21 by then. If we were figuring out his allowance, we can now figure out 3 times what equals 21. And he gets $7 a week. Well, this 3 is 3 times that x. These are linked. They are one number. We have a variable here, but this is a number that is coefficient. It is co with the variable. It changes what the variable could be. Because what if I changed it to this? Would that change the value of x at this point in here? It would, because 10 times something equals 21, but it ain't 7. So the numerical coefficient affects the variable. So, to review, if I have 2 plus 3x equals, hold on, I gotta think about this. Can someone identify for me a numerical constant in this? Yes, Jonathan.
8.
8. 8 is a number, and it's always going to be 8. That does not change. It is a numerical constant. Number that stays the same. Can someone identify a variable for me? Yes, Jimbo.
X.
The x, yeah, the x is a variable. That could change. I could say that x is worth one thing or another. You bet. Now I need a numerical coefficient, or a number that is cooperating with a variable. Yes, Humperdinck.
A 3.
A 3? Yes, the 3 is times the x. It is a number that is coefficient, or is cooperating with the variable. Excellent. Okay, take a look up to the front. We've got a problem on 1.3 here. It says Taya won some money in a competition. She's got 2 choices. Choice number 1, $20 a week for 1 year, or $400 cash now plus $12 a week for 1 year. We got to figure out which one is worth more. Now I'm going to lay this down as some algebra. We got $20 a week for 1 year, right? Okay. So could I go $20 a week like this?
Yeah.
And that's what? Times how many weeks in a year?
52.
Yeah. Okay. So there's 52, okay, for 1 year. And she's got $400 cash plus $12 a week for 1 year. So these are what we're trying to figure out. Once we figure those two out, we can compare them, find out which one is more. So let's figure that out on our boards. Use your algebra, and we'll see which prize she should take.
Mr.
All right, let's take a look at this. So we figured out right away that there's 52 weeks in the year, so W would equal 52. Can I make sure all eyes are up here? Because we're going to solve this one up. So what I'm going to do, I'm going to plug 52 right in where the W is. So I'm just going to ask you once again,